Hello everyone. In this project we are going to see how we can detect the faces in an image. So this is the image that I'm going to use. It has 5 faces. So we'll write a script which can detect the faces out of this image. So I've kept this image here at this path and set this path as my default workspace directory in MATLAB. I'm going to open up a script and write the program to detect the number of faces in this image. Okay, so the procedure goes like this. Firstly, we'll read the image, which is okay. Then we'll get the face detector object. Face detector object. Now this face detector object has nothing to do with our image. It is just an object which has the information of detecting the faces. So it's just an implementation of an algorithm which can detect the faces out of an image. Then the next step is we'll use face detector object on our image A and get the faces. So we'll study another function here which will use this face detector on our image and get the details of the faces. So when we say the details of the faces, it is going to output all the geometric details of the faces, which is precisely the number of faces and their x and y and width and height, coordinates and size. Okay, precisely the output at this point will look like a matrix m cross n, where m will be the number of faces and n will be 4, and these 4 parameters will be x, y, width and height. Okay, so this is called the bounding box of this image. Okay, so bounding box is going to have the information of the faces. Now the next step is we'll annotate these faces on the top of the image, original image. But in this step we'll mark these faces back to the image so that we can see where it has identified these faces. Then after that we'll display the number of faces in a string. We'll display this part, now that how many faces it has detected. Let's see the functions which we are going to learn in this program. Firstly, for getting the face detector object, here we'll introduce a function which can get a face detector object. Then here we'll use a function which can use face detector and A to get the bounding box. This bounding box will be having geometric details of the faces. Then in the next part, in annotation, we'll see how we can annotate an existing image. Okay, of course we'll pass the image here and the details of the bounding box and how we can label them. And lastly, in this step of displaying the string, we'll see a couple of string functions which are very common. So let me begin with this first step of reading the image. This we already know, imRead, and the name of this image is, I think, faces1.jpg. So it can support RGB or a grayscale image, so we don't have to convert it. Now we can get the face detector object. We'll store this in face detector only. And the function is vision.cascade object detector. So it's a big one, you have to remember it. You can see it is similar to the one which is studied for reading a video file. Yes, it's also a system object like that one. That was vision.video file reader. Here it is vision.cascade object detector. The difference is there we were applying that object onto an existing video, and we were applying this function onto an existing video to get the object. But here in this case we are just getting the information of the algorithm. The face detector object is not going to perform on this image right now. It is just going to have the details of the algorithm which we can later on perform on this image. Okay, so it's a system object. Just remember this part, vision.cascade object detector. Needless to say, it is case sensitive. Okay, so it is not going to accept anything. We can just put a semicolon here, but before that, since it is not accepting anything, we should put empty parenthesis. Okay, here later on you can see that can accept some inputs based on the things that you want in face detector, but right now we are going to keep it simple. We are not going to pass any arguments to this, so we are just going to get the details of this face detector object. Okay, now that we have got the face detector object, we can apply this object onto our image. Okay, so that we can get the bounding box of the faces. So here we are going to get the bounding box. I'm going to store that in B box, and this function is step. Although it is the same function which we used for getting the frames out of a video, but the function here is completely different. In fact, this same step function behaves differently with different arguments. So here in this case it accepts the image and the face detector object so that it can return the bounding box of this image. So let me explain what it is going to do in this step. It will open this image and then it will apply this face detector object over this image. Then using the algorithm for detecting the eyes and nose and the structure of this face, it is going to store the details of these geometries 1, 2, 3, 4, 5. Okay, so the output is going to look like a 5 cross 4 matrix, where 5 stands for the number of faces in this image and 4 is the constant parameter which is going to have the information of x and y and width and height of all the images. Okay, so x and y are the coordinates and width and height of the bounding box. So how big the face is, that will be reflected in this bounding box. Now once we have got the details of this bounding box, we can annotate the image using this. So here let's store the output image in B, and the function is insert object annotation. So here in the arguments you can see that we can pass these 4 values. First, I is the image data, then shape can be either rectangle or circle. This will be the shape of the annotation. So this is the mark on the image that is going to look like, and then the position of this annotation, where we want to put the annotation. Now we want to put the annotations on the faces of this image, right? So we'll pass here the B box, and the interesting part here is this B box is going to have the exact same syntax which this shape requires. Okay, so this shape here requires a matrix M cross 4, where M is the number of annotations and 4 should be x, y, width, height, which is the same type of the B box. So we can directly pass the B box here, and this label is the name which we are going to call with the annotation. So label on the annotation. Okay, let's pass these 4 parameters here. First is A, then shape I can pass as rectangle, then B box is the position where this annotation is going to lie, and label I can say as face. So it is going to put 5 annotations over the image. Now at this point we can display this image with annotations. Here I am show B, and title I can put detected faces. So that's it, we have got the image, and now we want to print the number of faces on the console log. I can do the string concatenation, and firstly I'll get the number of faces. So the number of faces is the row index of this B box, right? So I can say that number of faces I can store in n, and it could be size of B box comma 1. So that will give me the row index of B box. So I have in n I have stored the number of faces. Let me convert this n into a string. So I'll say strn is equals to num to str. So it will convert a number to string, so that we can use the string concatenation. Now we want to use the string concatenation and store the string in strcat, string concatenation. Now I can say the strings number of detected faces, and then we can concatenate it with n, strn. It is fine now. So you can see that we have used a number of string functions. Let me use another one, which is display this str. Now here at this point we are getting the number of faces using the binding box, the size of bounding box. Then we are converting this number into a string so that we can do this string concatenation of these 2 strings. One is number of detected faces r, and then I'm concatenating it with the number of faces. Okay, so here I'm using strcat to concatenate these 2 strings that I've stored in str. Then I'm displaying that string with disp. Okay, so now this command is going to be shown in the console log here in the command window. You can see that. So I think the program is completed now. Let's just go through the program once again, and we'll see the details in the command window later. So firstly we're doing the image read, that is fine. Then phase detector using vision.cascade object detector with no inputs. So once we have got the phase detector, we are applying that phase detector on A so that we can get the bounding box of the faces. So here, as we said, this will be a 5x4 matrix where the row index is the number of faces and 4 is x, y, width, height. Okay, so all the geometric information of the faces are present in this bounding box. Then we are going to use this bounding box here for inserting the annotations on this image A, annotations of type rectangle and of label face, position B box. Okay, so we are putting the annotation on an image B, and then we are displaying this image B with the title detected faces. Then we are performing the string operation so that we can display the number of detected faces. Now we are done with the code. We can save it. Detect faces. Okay, I am running it. So it should display two things. Here it has run this file, but it is not printing the output yet. Let's just wait. Okay, so it is giving an error somewhere. Let me debug it. The values of the num and den properties must be row vectors where each vector is non-empty. This is in line number 96. Okay, here in this code, this particular thing. Step A comma phase detector. Okay, I'm really sorry I swapped these two parameters. Let me correct it. Here the phase detector is the first parameter as they are saying in the error, and image is the next. So I'm going to run it again. Okay, it is displaying correctly. You can see that it has detected all the faces. It has put the rectangular annotations with label face, and that's it. That's how we can detect the number of faces. Here you can see that it has printed it as well. Number of detected faces are 5. It is not giving a break here because I think I haven't put here, so I should better put a break like this. I think it will display it correctly then. So that's it. That's how we can detect the number of faces. Let me do a quick analysis what it has done. So phase detector object it initialized. If I try to print that, it is not going to have much information. It will just give me some basic properties of this phase detector: min size, max size, scale factor, merge, threshold. Nothing we can take a note of. So phase detector is anyway going to have much more information so that it can perform this algorithm on the image. Now B box, let's see how B box is looking like. As I've said, it is a 5x4 matrix. These are the 5 x indices, these 5 y indices, then the widths, and then the heights. So this first you can see is 38x38, then 42x42. Okay, so that's how it is doing this detecting the faces. So this is the information of the geometric details of the faces. So that's it. And I can print, it should be 5. And what else is there? That's it. Otherwise we have printed the B already. So I hope you have enjoyed this project. It is really good, and it has a lot of possibilities. You can dig up the functions and other parameters on your own. Goodbye.